Income elasticity of demand comes under the category of price elasticity of demand. It measures how much quantity demanded is sensitive to changes in income. Do not get confused with prices because that was price elasticity of demand where we computed how much quantity demanded is sensitive to changes in price level. And we say quantity demanded is sensitive to changes in prices if quantity demanded changes considerably a lot due to a small change in price. And we say quantity demanded is insensitive to changes in prices when quantity demanded changes a little bit due to changes in prices. So remember income elasticity of demand, you compute it via this formula, change in quantity demanded over changes in income because this is income elasticity. So if you remember, I mentioned before, whenever we are talking about income, you have to be very clear, is the scenario about a normal good or an inferior good? Normal good are those goods as your income rises, you demand more of a particular good, and as your income decreases, you demand less. Like your income rises, you demand more luxury cars. So, due to this phenomena, normal good, they possess a positive income elasticity. The sign is positive. Whereas for inferior goods, the sign moves in opposite direction. As your income rises, you demand less of a commodity. Let's say you demand less second-hand mobiles. Or if your income decreases, you demand more high quality products. So due to this phenomena, income elasticity possesses a negative sign. That's all you have to know with respect to income elasticity of demand, whether the sign is a positive or it's a negative with respect to income elasticity. Cross price elasticity states that how quantity demanded of one good responds to changes in price of another good. So if you emphasize on this statement, you will remember the determinant of demand, that is change in price of related goods. In that determinant, we had cases of substitute and complementary goods. As when price of one substitute good increases or decreases, remember we used to check the effect on the market of another substitute good. And same was the case for complements. So cross price elasticity of demand is computed via this formula, percentage change in quantity demanded of good 1 divided by percentage change in price of good 2. And as it's related to price of related goods, so you have to be clear whether it's a substitute good or it's a complementary good. For income elasticity of demand, we had to be very clear regarding the signs. Is it a positive sign or it's a negative income elasticity? Here we have to be sure about the value, as in the number is a positive number or it's a negative number. So substitute goods possess a positive cross price elasticity value, whereas complements, they possess a negative cross price elasticity. For substitutes, it's positive because let's say if price of butter rises, we know that the demand for margarine will increase. And if the price of butter will decrease, the demand for margarine will decrease because people will go buy butter. It's cheaper now. So again, the sign move in similar direction for substitute goods. That is why cross price elasticity is a positive value. Whereas for complementary goods, the concept of complements are same because for example, let's say petrol in car or electricity or TV. So When there is an increase in price of electricity, you watch less television. Or when there is an increase in price of petrol, you drive less cars. So the sign moves in opposite direction. That's why cross price elasticity for complementary goods is a negative number. So now we are done with price elasticity of demand and its type. Now we have to analyze what is the relationship of total revenue elasticity with respect to prices. Total revenue can be affected due to changes in elasticity. So generally three questions arises in this scenario. What happens to total revenue when demand is elastic? What happens to total revenue when demand is inelastic? And what happens to total revenue when demand is unit elastic? So it's also important to remember their coefficient value. But for the first one, when demand is elastic, total revenue and prices moves in opposite direction. As in when price increases, total revenue will decrease. Or when prices decreases, total revenue will increase. For the second scenario, when demand is inelastic, remember in that scenario, price and total revenue will move in similar direction. As in, if price rises, total revenue will also increase. If price decreases, total revenue will also decrease. And the final one is what happens to total revenue when demand is unit elastic. So the coefficient value of unit elastic is equal to 1. So total revenue will remain constant regardless the change in price, whether price is increasing or price is decreasing, the value of total revenue will remain exactly same. So to analyze those scenarios first, it's important to understand what is total revenue. In simpler words, it's the amount a firm receives for sale of its output. Or you can say it's the amount which is paid by buyers and received by sellers of a good. And it's computed via this formula, price into quantity. So here we will analyze how do you depict total revenue on a graph. This is a demand graph. I haven't drawn the supply curve so you don't get confused. So remember total revenue is price times quantity. So if you look at this graph, the price is 5 and quantity is 100. So 5 times 100, your total revenue is 500. So this gray box, or you can say the height of box under the demand curve with given price and quantity, or the area, the square of the box with the given price and quantity is total revenue. This is how you depict it graphically. So let's analyze the case of inelastic demand, as in what happens to total revenue when price increases. So you know the rule of thumb. In case of inelastic demand, price and total revenue moves in similar direction, as in when price increases, total revenue rises, and when price decreases, total revenue falls. So let's analyze it via this graph. Here you see that the price is 5 and quantity is 100. So you compute the total revenue, which is 5 times 100, 500, and you depict it graphically. The height of the box starting from price 5 to quantity 100, the area below the demand curve, all this box is total revenue. But the question arises, what happens to total revenue when price rises? Let's suppose price rises from 5 to 7. Definitely when price rises, you apply law of demand. That is, An increase in price leads to decrease in quantity demanded. So at price 7, quantity demanded is only 90 and the total revenue is 630, which is price times quantity, that is 7 times 90. So this new price changes your total revenue. Previously it was a square, now it's a rectangle. The height of the box from price 7 to quantity 90. So you notice the extra revenue from selling at a higher price is greater than the lost revenue from selling fewer units. So additional revenue is this pinkish box and the lost revenue is this rectangular gray box, or you can say the difference from 100 to 90. That's the lost revenue because previously you were consuming 100 units, now only 90 units, so there is a fall in quantity demanded. But despite of this fall, total revenue has increased because it's inelastic demand. Remember, in inelastic demand, quantity demanded is not so sensitive to changes in prices. So for case of elastic demand, price and total revenue moves in opposite direction, as in when price rises, total revenue falls, and when price decreases, total revenue rises. That's because of the nature of commodities. Remember, in elastic demand, the commodities either they are not necessity goods or maybe they have a lot of substitutes so people can switch to other substitute if price of any substitute good rises. Other than that, the commodity can be in long run, as in if price of any product rises in long run, people have more choices and have more time to adjust to changes, so elasticity is large. So initially you're at price 5 and quantity 100. So your total revenue is 500. You can depict it graphically, the height of the box, the square box, which is depicted below the demand curve. That's your total revenue. So suppose your price rises from 5 to 7. Again, we apply the law of demand. That is, an increase in price leads to a fall in quantity demanded. And that's what elasticity measure, how much more or how much less quantity demanded is changing. So here you notice an increase in price is not much significant as compared to a fall in quantity demanded. So your new total revenue is 420, which is 7 times 60. This is smaller than the previous total revenue. Previously it was 500, now it's 420. Now the question arises why there is such a big fall in quantity demanded in total revenue, because it's elastic demand. So you notice the revenue you have gained from selling at a higher price, which is depicted by this pink box. This is smaller than the revenue you have lost by selling at a higher price. So the lost revenue is this grayish box, the difference between 100 and 60, because previously the demand was 100, now it's 60, so there is a big fall. So selling goods at a higher price is not a good option because quantity demanded has decreased more than the increase in price level, which leads to a fall in total revenue. So this is not profitable for commodities in elastic demand.